then now you're going to multiply these numbers. So just do second.
I'm going to slowly start to catch up to you guys. Oh. All right, so I think the two hardest problems on here are probably 1F and 3B. I believe. It's by design. Yes, real quick. What? Oh, hold on. We're going to go over everybody. Just have a little mini rant. I hate that you're going to have problems where you have to think about them. I'm not going to tell you exactly how to do everything. I'm never going to test you on something that I haven't fully explained. This is not a test. This is a thing. You can think about it. If you don't quite get it, we're going to talk about it. Not the end of the world. Doesn't mean shit. Okay. Now, the first few of these should be relatively simple. What's the probability they attend Grossmont? Yeah, 126 out of 176. Right, and then whatever you got when you divided it out.
0.7.
7159.
Okay, cool. I will take points off, not for every time you don't round correctly, but if you misround quite a few times, I'll take like a point off or something. Right, so if it was 71586 and you said 7158, that's not right. And you can moan about that all you want to, I don't give a shit. Business major, what's probably that? Yeah, there's 92 business majors out of, because anybody could have happened in the problem. I didn't give you any information. So the only one of these questions that's going to have a different bottom from 176 is E, because that's the only one I actually give you information. You could throw certain groups out. All right, what's this one? Computer science or attends Grossmont? Yeah, you could do 73 plus 126.
Minus 62.
But if you do this plus this, you counted those twice. I like it. Or you could have just done 126 Grossmont students plus 11 computer science. I didn't count yet, so you don't have to use the formula again. But if you do, it should work. Out of
176.
If you don't subtract the 62 off, I love it that some of you guys got a bigger number than 1. And you're like, well, I know that's not right. Beautiful. Yes, that's not right. What do you get on?
0.7784.
Sure. All right. Maybe. This is the one that everybody tries to make so much harder. And part of me doesn't blame you. I mean, the AND formula is weird. It's the last one we did. It's very strange. It's got the whole O-ring computer, the shuttle thing, whatever. So you're all like, oh shit. But here it's just how many people are math majors and Cuimaca students. There's only 2. In fact, another name for AND is intersection. I don't know if anybody's ever seen that. Anybody ever seen the actual symbol for AND? It looks like this. Right? It's like the opposite of the U that you put between interval notation to say or. That's U or U. I don't care. That's the or. And looks like an A that lost the middle bar. So another name for that is intersection. So what is the intersection of math and Grossmont? Get out of there, stupid. Math or Cuimaca? 2. So there's only 2 that are math majors and they go to Cuimaca. Out of what?
176.
Still out of 176 because they don't know something about the person. It could still be any of the 176 people. Here's the only one. Now, what's the bottom going to change to given their computer science major?
73.
Yeah, so it's out of those 73, so my whole world becomes this. Out of those 73, how many Grossmont students? 62. I love it. And what do you get there when you divide those? It's points. 8493. Okay. Now, I don't care how often I say this. When I ask this question on something, I'm going to have somebody write me a little paragraph about how you can be a Grossmont student and a computer science major, so it doesn't really need one that. No. Knowing they're a computer science major, does that change the probability they're a Grossmont student?
No.
Yes. If I know they're a computer science major, the probability they're a Grossmont student goes up quite a bit. So they do affect each other. This is what you check. I always am going to make you, somewhere in here, you're going to already have done the work you need. You just have to go find it and reference it. So here you would say, no, probability of Grossmont not equal to probability of Grossmont given computer science. 0.7159 does not equal 0.8493. Sweet. I don't need a big paragraph. In fact, a big paragraph normally means you're going to get it wrong. I just need this and the numbers. The idea and the evidence. Yes?
So just compare that back to your...
Yeah. So the probability somebody's a Grossmont student, just a Grossmont student in this sample, is 71.59%.
Yeah.
If I know they're a computer science major, that probability they're a Grossmont student goes up to 84.93. So did one affect the other one? Yes. So they're not independent because it is affected by the other one. If that number would have been 0.7159, then it would have been independent. Grossmont doesn't give a shit about if you're a computer science major or not, but they do. So there you go. How we feeling about that? Okay. The haunted house problem hopefully wasn't too evil. Very small sample, right? So it's going to be just like the poker chip problem eventually. And here I'm picking one person, so that's really nice. How many total people are there?
7.
21 total people. Be really careful. Triple check that number. If you get that wrong, I'm only going to take points off once. And then I'm going to check everything else based off of that wrong number. You guys, does it make sense? You don't suddenly get every problem wrong, because all your bottoms would be wrong. That would suck. If it did Scantron shit, that would really suck. No, I just take points off that one time. Double check that. Democrat would be 7 people out of 21, which is 33.3. Republican would be 12 out of 21.
5, 7, 1, 4.
Point who?
5, 7, 1, 4.
Thank you. Okay, I like it. So that's nice. I'm going to pick one thing that kicks ass. Now I'm going to pick 2 people, of course, with replacement. So I put them back in. I take them out. They're like, oh, thank you, and then I put them back in. So now I'm picking 2 people. So how many spots do I need? 2. It's and, so it's times. It's probably I pick an independent.
Yeah.
Yeah, the independent would be 2 out of 21. Put that person back in. The Republican would now be
12 or 21.
12 out of 21. And, whatever the hell that is.
0, 5, 4, 4.
0.0.
No. 0, 5, 4, 4.
Okay, we got it, Revenge. 2 Democrats. Again, I need 2 blank spots. The first one's a Democrat. That would be
7
7
or
out of 21. Put that back in. It's still
7 or
7 out of 21. And that'll be 0.1111. Okay, let me stop here real quick. Is that so far so good? Now, what's really funny is, if I were you, now, I'm basically going to ask you the same question again, but now I'm doing it without replacement. So you pretty much know it's going to be 2 out of 21 for the independent, but what happens now for the Republican? 12 out of 20, because I lost a person. Why is it still 12 at the top? Because I didn't lose a Republican, I lost an independent. Please let that be not that bad. And whatever the hell that is. 1/10 at that point. 0571?
Yes.
What about 2 Democrats? So now it'll be still 7 out of 21 for the first guy or girl.
6 over 20.
And now it's 1 less Democrat, 1 less person.
0.0952.
0952?
Yeah.
No, can't be right. This is 1/3, 2/20th. Yeah, point, yes, 10%.
We don't replace this, so we took one out. There's 6 left over.
Alright, I don't know why I put .10, put .1. Alright, so double check that. So 720 worse times 620, that's 1/3. 3 goes into 6 twice, 220 is just 10%. Or just playing the cop player. Okay, working our way up to this part B of 3. We'll do this first one, and then we're going to do a little side work for the second one. First thinks it's in the most important problem, so I'm going to have 4 spots. What goes in the first spot?
0.0.
Yeah, be careful. 7% is 0.07. You wish 5% was 0.5, because then your 5% bank account would grow freaking quick. But it ain't. Shit. So 0.07, so what's the rest of them? The other ones don't think that way. 0.93, 0.93, 0.93. And then whatever that is.
0.0563.
Is
Who
it
to what?
that 0.93 or 0.9? 9993?
Yeah.
Oh,
Careful. Yeah, it's not 0.07%. Right?
right.
So 100% minus 7% is 93%. I love it. So don't have 1 as a decimal and 1 as a percentage. It's never going to be good.
0.5630. 0.0.
0.
No.
Yeah.
Yeah.
Okay. All right. Now, let me do some work up here real quick to work up to part B.